dancing music. We were going to do a fundraiser one time, and I was going to have square dancing for it. And I was trying to remember what I'd done in middle school, and then I got those, and they were way, way more complex. So I have this weird square dancing music in my iTunes library, but thought that might get us started and going here today. We're looking at Systems 2 and linear quadratic circle notes, and we started with the first one looking at how do you graph circles, and we're going to now add a few more into it here, and we have lines, parabolas, and circles. So the first thing we want to look at is when we have a line, we have slope-intercept form of a line, which we like to use. How can we tell if it's a line? Well, we got to have a y to the first power and an x to the first power. So if we have something other than that, we got something else. We can have other numbers. There's some special cases that we can have with lines. You could have like x equals 3. That's a vertical line. And y equals -4. That'd be a horizontal line. Those are some special cases. But basically we're looking at is the exponent to the first power. Well, how do we graph? Of course, we've got, like I said, the special cases. When x equals a number, that's vertical. And y equals a number, that's horizontal. And I can't show you on here, but if you've seen me do that, I like to do x equals vertical, and you stretch your arms up, and then you make a y equals horizontal. Okay, so x equals vertical, y equals horizontal. So how are we going to graph that? Well, when it's in slope-intercept form, we're going to use y equals mx plus b. M is the slope, which is the rise over the run, and b is the y-axis intercept. Hopefully that's very familiar with us. We can also use the graphing calculator, and we could get points from plotting it that way. Now when you have a parabola, the standard form of that is y is equal to ax squared plus bx plus c. And here the key is that you're going to have y to the first power, and you're going to have x squared as the highest power of x. If you don't have that, if you don't have the x squared, you don't have the y to the first power, you don't have a parabola. So parabola, how are we going to graph parabola? Well, we like to find the axis of symmetry. So the axis of symmetry is going to be helpful to us. And remember that formula is x equals negative b over 2a, negative b over 2a, negative b over 2a, x equals negative b over 2a. And then from negative b over 2a, that gives us the middle. And we're going to plot some values. We're going to make a chart of x and y values. And we're going to plot those points up. Again, we can use a graphing calculator. It's going to save us a little bit of work. We don't have to substitute everything in. But parabolas, they're looking like they're either going to open up or they're going to open down, depending on the value of a. All right, and then yesterday we introduced you to the circle, and the circle is, not x, it's the quantity of x minus h squared plus the quantity of y minus k squared equals the radius squared. And so how can we tell if it's a circle? Well, in this case, we got to have an x squared plus a y squared. We got to have both of those. See, in a line, they're to the first power. In a parabola, only the x is to the second power. But in a circle, they're both to the second power, and you got to have that plus sign. Okay, so that's what we're looking for. So how do we identify? Well, the center is the point HK, and R is the radius. Okay, so remember the deal with the center is we're always switching the sign. When you put it into the equation or when you take it out of the equation, you're going to switch the sign. So we're going to look at a few here examples of where we graph. Now, again, what are we looking for? And excuse me, as I go back to the system. Systems, we're looking for the intersections. The intersections are the solutions on the graph, okay? If we were doing it algebraically and we were going to check, it's the values that make the left side equal to the right in all of the equations. So we're looking for the points of intersection. So as to start off, we have x squared plus y squared equals 16. Well, this is a circle. And the other one we have is y equals x. And this is a line. So identify those. You know, what are we working with here? Well, we're working with a circle. What's the center of this one? Well, what do we add to x? 0, y 0. R squared is 16, so we take the square root of that and we get a radius of 4. And over here on our line, we want to identify our slope, which is 1 over 1, and our y-axis intercept is 0. Okay. Now there's some different ways you could graph that line, but that's, that'll get us started here. All right, so we look at our circle, centered at the origin. I'm going to put up my center point. Now I'm going to plot my 4 radius points. 1, 2, 3, 4. I'm going north 4. 1, 2, 3, 4. I'm going south 4. I'm going to go 1, 2, 3, 4 to the east. 1, 2, 3, 4 to the west. And I'm going to, hopefully my circle tool will come up. Sometimes it wants to be a little stubborn here as we do that. Okay, so there is our circle. I'm not super happy with that, so I'm going to try that again. Okay, better, a little better. It's still off a little bit, but I think you get the idea there. I don't know if I can nudge that down or not. All right, now the line, start with our y-axis intercept. Remember, you always do the b first, and then you do the rise over run after that. So we start at the origin, we go up 1 over 1, up 1 over 1, up 1 over 1, and down and left, okay? Down and left. I'm going to use a straight edge. Here I'm going to use my line tool, okay? And we're going to go right there. So we're going to label these, okay? I got y equals x. And over here I've got this x squared plus y squared equals 16. All right, now, where are they intersecting? Are they intersecting exactly on the point? Well, in this case, fortunately, it's not asking us where they're intersecting. It's just saying what are the total number of points of intersection. And so these have 2 points of intersection. We'll get into some more where we got to be more specific, and we'll talk about that. But for right now, we have 2 points of intersection. They're here and they're here. Okay, so circle and a line, system, 2 points of intersection. Now, solve the following system of equations. So now we're not just looking for how many points they have. That solve indicates to us we're looking for the intersection. Now it might be singular, 1 point, it might be plural, and you know what? They might not intersect at all. Okay? Those are the 3 options that we can have. So I'm going to list my 2 equations. And as I look at this first one, I see y to the first power, x to the second. That's a parabola. And then I've got y equals 5x plus 3. That's a line. They're both to the first power. All right, so for my parabola, a is 1, b is 4, and c is 1. And I want to find my axis of symmetry, which is x equals negative b over 2a. X equals negative b over 2a. So the negative 4 over 2 times 1 is negative 4 over 2, which comes out to be negative 2. So in my table of values, I know that negative 2 needs to be in the middle. So I go less than that, as I go greater than that, um, and depending on the graph, we might need to add some more values to this. So we'll see where things go for that. So now what I'm going to do is I'm going to take those values and I'm going to enter this in on my graphing calculator. If you don't have a graphing calculator, remember you can just enter those values in. All we're doing is we're substituting in -5 in for x and finding what y equals. So this comes out to be 6, 1, -2, -3. And then one of the shortcuts, if you realize that, hey, here's our axis of symmetry, you're going to see symmetry in the y values. -2, 1, and 6. All right, so let's go ahead and plot those on here. So we're going to go left 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6. Okay, -4, left 4, up 1, left 3, down 2, left 2, down 3. Then we're going to come back up. And 1, 6. Okay. Now again, I may need more points. I don't know if I've got enough as it is. Remember, with our parabolas, we want to freehand those. We don't want to, wouldn't want to use a straight edge. We want to get that curve. All right, and then for our line, let's identify our slope, 5/1, and our y-axis intercept is 3. Okay. Now, if you have trouble with slope, you can remember the slope house, positive slope, you're going up and right or down and left. That helps some people out. Okay, so let's plot those points. So I go 1, 2, 3. Okay, now I'm going to go up 5, 1, 2, 3, 4, 5, and I'm going to go over 1. 1, 2, 3, 4, 5, over 1. The next one would take me off my grid. Now let's go back and go down 1, 2, 3, 4, 5, and to the left one. And I see here that's a point where it intersects the graph. But I'm also noticing on my parabola that I don't have enough points on my parabola plotted yet. Well, that's no big deal. We can just simply add a point to that. So I'm just going to come over here in my chart and I say, well, what's it when it's 2? Well, hey, when it's 2, it's 13. So right 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wouldn't you know, that's that same point of intersection. So I just want to extend that graph up. I could do it on the other side. It would be 13 over there just to make it look a little prettier. Okay. And let's not forget our line. Let me get back here. Okay, so we're right 5, up 5, right 1, or down 5 and left 1. So down 1, 2, 3, 4, 5, and to the left 1. Again, use your straight edge, and mine's off a little bit. See if I can make that a little bit more accurate. It's tough because it's a little thick and these grids a little small there. Okay. All right, so let's go ahead and label. The line is y equals 5x plus 3. And for our parabola, it was y equals x squared plus 4x plus 1. And then let's make sure that we label these points of intersection. So we had the point 2, 13, and we have the point here, which is -2, -1. And those are going to be our solutions. So in this case, we need both of them. Okay. So it's going to be the point 2, 13. Make sure we got a parentheses, and the point -2, -1. Okay, so that was a parabola and a line. Again, there may only be one, there may be none. In this case, there was 2. And you just see sometimes you have to make some adjustments. Okay, one of the ways you can do that is you could graph both of those initially in your graphing calculator, and you could plot those out. All right, number 3, find the number of points of intersections of the graph. And here's our first graph. We have x plus 1, quantity squared, plus y minus 2, quantity squared equals 16. So I'm seeing an x being squared, a y being squared. I got a plus sign. This is a circle, so I want to think center radius. Remember, we're going to switch the signs. Positive 1 becomes negative 1. Minus 2 becomes positive 2. R squared is 16. Take the square root of 16, and our radius is 4. Let's go ahead and plot that just so we can get that out of our way. So I'm going left 1 up 2. There's our center. Going to go north, south, east, and west 4. 1, 2, 3, 4. Down 1, 2, 3, 4. To the right 1, 2, 3, 4. To the left 1, 2, 3, 4. Okay, there we go. And let's get our circle tool here. See if we can plot. Okay, good. All right, now that was our circle. Well, what else do we have? Y equals x squared minus 2. Now, it's in a little bit of a different format, but we should recognize that this is a parabola. Okay, and in the parabola, the value of a is 1, b is 0, and c is negative 2. See, there's no x term written, so that's when you have 0. So x equals negative b over 2a. Formula for the axis of symmetry. So we have negative 0 over 2 times 1. Well, hey, 0 divided by anything is just 0. So for our axis of symmetry, it's going to be in the middle. That's nice. So we do negative 1, negative 2, negative 3, 1, 2, and 3. So depending on how you're doing this, if you have your graphing calculator, you're going to go to your y equals, you're going to enter in x squared minus 2. You're going to use your table here and fill in the values. If you don't have a graphing calculator, you're just going to enter them in. You know, how do we do that? Y equals negative 3 squared minus 2. Y equals 9 minus 2, which is 7. Okay, and you could keep doing that. So I'm going to use my graphing calculator just to get those values. Recognizing that here's the axis of symmetry, I know I've already got my other 3 now, negative 1, 2, and 7. And let's see if that's going to be enough for us to get the points of intersection. So we're going to go left 3, up 7, 1, 2, 3, 4, 5, 6, 7. Okay. Then we're going to go left 2, up 2. Okay. And we're going to go left 1, down 1. And then we're going to go 0, down 2. And then we're just going to kind of repeat that process. 2, 2, 3, 7. Okay. Got to kind of freehand this here. Okay, now again I see here that my, so I got x squared minus 2. For my circle, I've got x plus 1, quantity squared, plus y minus 2, quantity squared equals 16. All right, and we see here that we have 2 points of intersection. Okay, now that one is pretty close, but it is a point of intersection there. So find the number of points of intersection. Okay, 2 points of intersection is our answer here. Okay, so that, oh, hang on, we got one more. Nope, we got it. All right, so there's some systems there. We've got a circle and a parabola. We've got a parabola and a line, and I think back here we did a circle and a line. So obviously we can have some different combinations, and tomorrow we'll do some more practice with that in Systems 3. All right, so have a good night, and I'll see you soon.